Hello again. So this week we're going to look at numerical sort of problem solving skills for the second skills week. So we'll start off by looking at percentages. So first up, there's three different types of percentages we're going to look at. The first is percentage of a total. First of all, what you want to do in these problems is make a fraction. So the number you want as a percentage goes on the top, and the total number, whatever that is, goes on the bottom of the fraction. Secondly, you're going to then multiply the fraction by 100, so it's number over total, and then times by 100 to get your percentage. So the wee example here, we've got 3 pupils in the class of 20 who wear glasses. What percentage of the class would this be? So 3 pupils is your number. The total number, as you're told, is 20. So that's our little sum, 3 divided by 20. And as we say in the second step, we multiply it by 100. Remember that over in these things means divide. So it's divide you're typing into your calculator, giving us an answer of 15%. Sometimes you are given the percentage. So if you see the percentage symbol on the page and you're asked to calculate it, that would be the kind of clue to use this approach. The first step, as you've no doubt been taught in maths, is to divide the big number, the number you're given, by 100, not the percentage, but the number by 100. And this gives you effectively 1%. If you divide anything by 100, that will give you one of those units, 1%. Then you multiply the percentage that you're given. So for example, 5% of a class in S1 are aged 11 years. If there's 60 in the class, how many would be aged 11? So we take our number, which is 60, we divide it by 100. That's step one. And that gives us 0.6, and then we take 0.6 and simply times it by the percentage, which is 5. So 0.6 times 5 tells us that 3 pupils in the class of 60 are aged 11. The most common percentage problem in biology, though, is percentage change. And in this one, we do a subtraction to work out the change in the readings, and we make a fraction. I'll give you an example in a moment. So it's change over initial. You sometimes use this as change over start or change times original. And then again, multiply it by 100 to get your percentage. So in the example here, excuse me, that times 100 jumped down a wee bit there. A potato weighed 650 grams at the start of an experiment. After being in salt solution for 1 hour, the potato weighed 550 grams. And if the keen eyes amongst you will spot this as an osmosis question, but it's all skills, it's all problem solving. Calculate percentage change in mass of the potato. So obviously the first thing we do is do our subtraction. So we subtract 550 from 650, which gives us 100 grams. So that's our change. The original, well, it started off, whatever one it started at, is the 650 grams in this example, where it starts at. In this example, 650. So we divide 100 by 650. So it's change over start, change over initial, if you like. And then step 3, we times it by 100, and that gives us 15.4. Apologies again, the 650 has slipped over here. It should be under the 100 at this point here. So that gives us 15.4%. Now, top tip here is that if it's a percentage increase, you won't usually be asked if it's a percentage change. It will ask for either a percentage increase or a percentage decrease. If it's a percentage increase, it's not always easy to work out what the starting value is of your two numbers. So if it's a percentage increase, the starting value will always be the lower of the two numbers because it's got to go up. And if in this one, like it's a percentage decrease, then the initial value will always be the higher of the two numbers. And as you'll see from problems later on, it's not always easy to work this out.